So we're going to look at number 6. Football kicked from the ground, initial velocity of this, at an angle of this above the horizontal. How long is the football in the air before it hits the ground? Alright? So, number 6. And, let's see. The football is a projectile. Right. So, therefore, vertical acceleration, because it's in free fall, is little g down, and horizontal acceleration is 0, right? Then, now we think of this one more precisely, and I would think of things like it lands at the same height. Buried the height in there. Height it started. So it lands at the same height as it started. Anything else interesting going on? Maybe I might want to use the fact, well, I'm just trying to think of what they asked me to look at, and they want to know how long is in the football in the air before it hits. Okay, so they're looking for the amount of time. All right. So I might think about things like, as soon as I think about it landing at the same height that it took off at, I start thinking how symmetrical it is. You know, it's going to go vertically, it's going to go up, stop, and come back down. So, and because it lands at that same height, I know whatever velocity it goes up with, it's going to come down with the opposite velocity, right? So some of those type things could be in your Y. But all right, so I need to first, I want to separate it into the horizontal and vertical. I need to first, therefore, separate my initial velocity into the horizontal and vertical, and I do that by knowing that it's 22.2 meters per second, and it's at an angle of 40 degrees to the horizontal. So that's going to have a horizontal component and a vertical component. And the vertical component would be 22.2 meters per second sine 40 degrees, because it's opposite the angle, and the adjacent component would be 22.2 meters per second cosine 40 degrees. So when it is kicked, when it leaves the ground, that's the components of it. The biggest mistake people usually make is thinking that somehow is showing you also the path it follows. That's just about the initial velocity, nothing about what the path is. So at this point, I need to separate into my horizontal and vertical components with my time bridging the gap. So over here I'll do horizontal, here I'll do vertical. Alright, so horizontally I know it has a velocity of 22.2 meters per second, cosine 40 degrees. It has an acceleration of 0. Yeah. And then I don't know much about where it starts or where it ends up. We call where it starts at 0 meters. Let's see what I know about the vertical. That would be the VRT there, John. I know its initial velocity is 22.2 meters per second, sine 40 degrees. Its acceleration is downwards, negative at 9.80 meters per second squared, as long as I'm going to call down negative. Its V final, if I think about the symmetry here, if I think about this football starting here, going up and landing back here, whatever it took off here with the velocity in that direction, it's going to land here with a velocity in the exact opposite direction, which means horizontally we know that there's no change in it, but vertically we know it starts up at this green vector here, goes up, and vertically the velocity is 0 at the top, and then it has just the same amount of time to come back down and gain back just as much velocity as it lost. So the symmetry actually tells me the V final here vertically is going to be negative 22.2 meters per second sine 40 degrees. My D naught is 0 meters. My D final is also 0 meters. I land back at the same height that I took off from. The horizontal, because the horizontal starts here on the left and lands way over here on the right, and they don't tell us how far. Right? And even if we didn't realize this, the fact, this symmetry idea that, whatever velocity I go up at, if I'm coming down at the same level, I land at the opposite velocity. If we used, say, we could always, I'm just going to put it in brackets, if we did V final squared equals V initial squared plus 2A delta D, our delta D is 0. So 0 times our A times our 2 is 0, and we end up with V final equals V initial squared. And so it either, when it lands, it either has to be moving up at the same speed as it was moving up when it started, or opposite. So this can kind of give us an idea that, hey, wait a minute, something's going on here. But now we want to find the amount of times, since we don't know that that's in between. I'm going to use that V final equals V initial plus A T as my method. I know V final is negative 22.2 meters per second cosine 40 degrees equals 22.2 meters per second cosine 40 degrees. Double checking that I made the final one negative and the initial one positive, plus negative 9.80 meters per second squared times t. And so that was my initial vertical velocity, my final vertical velocity, my acceleration, which is negative 9.80, and solving for t. Yep. Oh, I did. Thanks. Must be Monday. Thank you for noticing that. Yeah, that should be sine. Sine 40. Good catch. And then I just mathematically solved that for time. Oh, my calculator, there it is. Huh? Plus negative 9.80 meters per second squared t. You sure? I get 2.91 seconds. I don't know if that's right yet. I'll have to check it. How did I plug it in? Well, let me put it in simpler numbers. Maybe that'll help. Okay. So let's say, and that's sometimes what I do. I've got negative 7 equals 7 plus negative 3x. How am I going to solve for x? So I'm going to get, first I need to get negative 3x by itself. So I'm going to bring the 7 over here and have negative 14 equals negative 3x. And then see that they're both negatives to make a positive, and then divide both sides by 3. And I get x by itself. So what I did is I brought the 22.2 meters per second sine 40, subtracted it from both sides. So I've got double that on the left, and then I divided both sides by negative 9.80. Yeah. Yeah, now remember your numbers are different though.
Yeah.
Huh? Sorry, I couldn't hear you right. Yes. Come on. Good. So, number 8. The ball is a projectile. Therefore, cell vertical is G down, and cell horizontal is 0. Number 8. And let's see. Ball lands lower vertically than it starts. How about also vertically, the ball goes upwards, middle, stops, and all right. I think rather than trying to draw it, I'm going to grab the, yeah, I know. I am. Technically, I don't even need the drawing, but it'd be nice. It'll make it clearer for you guys to understand. All right. All right. So let's see. Let's put some labels on here. My V initial is 13 meters per second, 71 meters, 41 degrees. 41 degrees, 71 meters, 13 meters per second. Right? Okay. I'm going to call here 0 meters in both directions. We'll call this positive and this positive. All right? So my 0 meter is going to be down at street level on the building. So the first thing I need to do is to separate my initial velocity into its horizontal and vertical components. Just out of curiosity, at 41 degrees, which one do I expect to be bigger, my horizontal or my vertical? My horizontal, right. Good. 13 meters per second, cosine 41 degrees, and 13 meters per second, sine 41 degrees. All right? This is usually the point I start thinking, okay, which dimension is going to be more restrictive? And in this case, the one that's more restrictive is the horizontal. Because I know it goes out 71 meters horizontally. I don't know how far it falls down vertically. So for this one, the horizontal, I think, is going to be more restrictive to us than the vertical is. So I'm going to start off with the horizontal side. I know, let's see. I know my velocity is 13 meters per second, cosine 41 degrees. My acceleration is 0 meters per second squared. V naught is 0 meters. D is 71 meters. And I'm not even going to bother writing anything in the vertical yet. So I'm going to use D equals D naught plus V initial T plus 1/2 AT squared, because that time is unknown, so maybe I can find that time and that'll jump me over to the vertical, which is where I really want to be. I know this whole term is 0 because the acceleration is 0. So I end up at 71 meters. I started at 0 meters. I had a velocity of 13 meters per second, cosine 41 degrees, and I move for a certain amount of time. And that amount of time is, let's see, 71, 5 parentheses, 13, cosine 41. I get 7.23669 seconds. Because I know my acceleration is 0, so no matter what, that whole term is 0. Yeah, that's one of the nice things about this side. Always the acceleration is 0. Yeah. So what I did is actually, and hopefully we'll have the app soon, so you can see me doing it on the calculator. I did 71 divided by, and I put this in parentheses. So that is this common time. Now horizontally, I know my initial velocity is 13 meters per second, sine 41 degrees. No clue what my final velocity is. My acceleration is negative 9.80 meters per second squared. Where I start horizontally is at, I'm going to call it H. Where I end up horizontally is 0 meters. That's all I know. I'm again going to use D equals D naught plus V initial T plus 1/2 AT squared. I'm looking, sorry, this is D naught, and this is D. Sorry about that. H. You could call it anything because it's the point you start at, and we don't know that height yet. That's what we're looking for. I picked H because it's the height of the building. So I'm going to end up at 0 meters, starting at H. My initial velocity is 13 meters per second, sine 41 degrees. My time, 7.2366 seconds, plus 1/2, negative 9.80 meters per second squared, times 7.2366 seconds squared. I just plugged in everything I knew. I knew the V initial, I knew the time, I knew the acceleration, I knew the time. So in other words, that whole thing is going to equal negative of my H. Okay? That's one way to think about it. Now, you could have set your starting point at 0 and the other at the bottom as negative H. But, yeah, I'm listening. Yeah. Yeah. And so I get, after all that fun calculating, I get H equals 195 meters. See if I'm right. Notice this is one that has a tutorial if you want to use it.
Tutorials are overrated.
Are they? What are they rated? Yay!
Go back to that.
I kind of wanted to see what